We have been learning ways to factor different polynomials. First step is always to check for the greatest common factor. And then if there are 4 terms remaining, we factor by grouping. If there are 3 terms remaining and the leading coefficient is 1, we have done reverse FOIL. If there are 3 terms remaining and the A term is greater than 1, we learned yesterday about a slide and divide technique. There are some special products that we can factor in a much quicker way if they turn out to be one of these special conditions. So we're going to think back to when we were doing special products of binomials. And if you remember doing this, we would have a binomial that is squared, and we would square the first term, so x times x is x squared. We would square the last term, so 4 squared is 16. And then we would take the 4 times the 1. 4 times 1 is 4, and then we would double it. Remember, we were taking the A times the B and doubling it. So 1 times 4 is 4, times 2 is 8, and we would go 8x in the middle. And these were perfect square trinomials. Today we're going to be taking those and we're going to be doing them in reverse. So that's just a reminder of what we did do. So first of all, you have to be able to recognize if it is a perfect square trinomial in order to use this method. So what we're going to do is first we're going to look at the first term. And we're going to ask ourselves, is that a perfect square? Can I take the square root of x squared? We can. The square root of x squared is x, which is x times x. Then we're going to look at the c term and ask ourselves, is it a perfect square? We can take the square root of 16, which is 4, so we're going to write it down. Now we're going to check it now to see if it is a perfect square trinomial. To do that, we're going to take the 4, multiply it times the invisible 1, and double it. So 4 times 1 is 4, doubled is 8. It does check to be a special product. So we're just, in order to factor it, all we have to do is take the square root of x squared, which is x, take the square root of 16, which is 4, bring the sign down, and it's x plus 4 squared. We're going to practice this several times, and this steps you through all the processes here. First, we have to check to see if the square root of the first term, we just did that. We checked the last term to see if we could take the square root of that. And then we multiplied the 2 and doubled it to see if we would get the middle term. So we're going to practice this a few times. There's the steps. So to check it again, we take the first term, 4x squared. We can take the square root of that. That would be 2x. We can take the square root of 9. That would be 3. We bring the sign down, negative. Now to check to see if this is truly a perfect square trinomial, we take the 2 and multiply it times the 3, the a times the b. 2 times 3 is 6. We double it, and indeed it does make 12. So this is a perfect square trinomial. So the factoring is just 2x minus 3 squared. So it's the same process. It just shows how we took the square root of the a and c. We checked the middle term, so we can write it as 2x minus 3 squared. Okay, so let's practice again. Taking the square root of x squared would be x. We bring the sign down. Taking the square root of 16 would be 4. Now we have to check it to make sure it's a perfect square trinomial. We multiply 2 times a times b. So the a term is 1. The b term is 4. That's 4 doubled is 8. This happens to be 9. It does not check as a perfect square trinomial. So we cannot factor it this way. We would have to use one of the other methods that we learned, such as reverse FOIL, since the leading coefficient is a 1. So it doesn't work for all trinomials, only perfect square trinomials that you have to check for. This does not check. Okay, let's try again. X squared, if we take the square root of x squared, that would be x. Take the square root of 4, that would be 2. Bring the sign down. Now we have to check it. To check it, we do a term, which is 1, times the b term, which is 2, and double it. And indeed, we did get 4x, which is this term. So to factor it, it is just x plus 2 squared. So it can go really fast if it is a perfect square trinomial. Let's try this one. X squared, the square root is x. The square root of 49 is 7. I bring the sign down, minus, so let's check it to see if it is. The a term is 1. So we have 1. Whoa, it went crazy on me. 1. So we have 1 times the b term, which was 7. We double it. It's 14. It does check. So our factor would just be x minus 7 squared. Trying again, 9x squared. We can take the square root of 9. That would be 3. X squared, or taking the square root of x squared would be x. So we took the square root of this term. Now we look at the c term and take the square root of it. That would be 2. We bring the sign down. So it might be this, but let's check it to be sure. We go 3 times 2 is 6, and we double it as 12. It does not check to be a perfect square trinomial because 2 times 3 is 6 and doubled is 12. That does not check. So instead of using this method, we would have to use the slide and divide technique that we learned in our last lesson. So it does not work for all trinomials. On this one right here, you can tell by right here, there being a subtraction sign, that this is not going to work. Because the square root of 4 is 2. 2 times 2 is a positive 4. If it happened to be a negative 2 squared, negative 2 times negative 2 is also a positive 4. This sign right here has to be positive, or this does not work. So this is also not a perfect square trinomial because of that subtraction sign there at the end. The last term must be positive. Okay, we're going to pause here for a minute, and I'm going to look at part of your worksheet with you. Okay, we're going to practice again with this paper right here. We're going to check to see if these trinomials are a perfect square. If they are, we're going to factor it. So again, we take the square root of the first term. Square root of x squared is x. We take the square root of the last term, which would be 3. We bring the sign down, so that would be plus 3. We want to check it to see if that checks. So we have 1 times 3 is 3. We doubled is 6. It does check. So it's x plus 3 squared. Number 2, 4x squared. If we take the square root, that would be 2x. Take the square root of 25, which would be 5. Bring the sign down. Now we need to check it to see if it's true. 2 times 5 is 10, and we double, it checks as 20. So that is the factored. Number 3, 36x squared. Take the square root of 36x squared, which would be 6x. Bring the sign down, which is a subtraction sign. Take the square root of 16, which is 4. Now we check it. 6 times 4 is 24. Doubled is 48. It does not check. So we would say no, the middle term is not 48. On number 4, take the square root of 9x squared, which would be 3x. Bring the sign down. Take the square root of 4. Check it. 3 times 4 is 12. Oh, I didn't take the square root of 4. Messed up there. Went too fast. Let's say that doesn't seem right. Oh, nice eraser there. Good job, eraser. We'll just write over it. The square root of 4 is 2. 3 times 2 is 6. When you double it, it is 12. It does check. So it is 3x minus 2 squared. So that's just a little more practice there on that. So let's go back to this. Look at the second half. This is the one that you're going to use the most often with our quadratic unit, which is coming up, is this next one. We're going to look for the difference of two perfect squares. Now listen to what that says. The difference means it has to be a subtraction sign. So always check for that first. Then we have to see if the two terms are perfect squares. In order for the two terms to be perfect squares, the coefficients in front have to be perfect square. Well, we have an invisible 1 right here. Is 1 a perfect square? Well, 1 times 1 is 1, so 1 is a perfect square. The square root of 1 is 1. The powers, the exponents, have to be an even number. We can take the square root of x squared. That would be x. We can take the square root of x to the 4th. That would be x squared. We can take the square root of x to the 6th. That would be x to the 3rd. So the exponent has to be an even number. If it is an odd number, it is not a perfect square. So we have to check for that. And then we have to check also to see that the constant, or whatever number you have without a variable, is also a perfect square. 81 happens to be a perfect square, 9 times 9. Because this checks as the difference of two perfect squares, we can factor it by simply saying, what is the square root of x squared? X. What is the square root of 81? 9. And then we're going to write it twice, once with a minus sign, once with a plus sign. X minus 9, x plus 9 is how you factor the difference of two perfect squares. So let's try that here. 9b to the fourth. We can take the square root of 9, that would be 3. We can take the square root of b to the fourth, that would be b squared. We can take the square root of 16, that would be 4. We can take the square root of q squared, that would be q. So they're all perfect squares, so we write it once with a subtraction sign, and then we write it one more time with an addition sign, and we have factored it. And that's just going through the steps. The coefficients were perfect squares. This is just breaking down what we just did. The variables were both even. There were no constants, so we factored it like that. Okay, another example. If we look at this, immediately when I look up there, I see the number 7. 7 is not a perfect square. So we automatically know that it is not a perfect square. This is not the difference of two perfect squares. We cannot use this method for factoring. Is this the difference of two perfect squares? Difference, there's a subtraction. 1 is a perfect square. The square root of 1 is 1. 2 is a perfect square. The square root is 2. X squared is a perfect square. The square root is x. So we write it once with a subtraction sign, once with a positive sign, and we have factored it. Factors that quickly. If you look up here quickly, are both of these perfect squares? Is it the difference of two perfect squares? Well, p to the 8th would be p to the 4th. 49 would be 7, and q to the 6th would be q to the 3rd. Everything's a perfect square, so we write it one time with a subtraction sign, one time with a positive sign, and it checks. And I do not know why my PowerPoint keeps putting that line, but it's being weird. Look up here. Do you see anything that would keep it from being the difference of two perfect squares? Right off the bat, I see an exponent of 5. That's not an even number exponent, so I cannot use this method. That is not the difference of two perfect squares, so we cannot use this method to factor it. Now, if you go back to the page we were working on, we go down to the bottom part. We're going to practice this again. We're going to skip number 5 and go to number 6 to check to see if these are the difference of two perfect squares. It is the difference. We can take the square root of x squared, which is x. We can take the square root of 16, which is 4. It is the difference of two perfect squares, so we write it one time with a subtraction sign, one time with a positive sign. If there is a number that's larger, and you're not sure if it's a square root, a perfect square, you can take your calculator and type in, what is the square root of 200? If there is a decimal involved, it is not a perfect square. You will find out here that the square root of 200 is not a whole number. It is a decimal, which means it's not a perfect square. So we cannot use it on that one. This is not the difference of two perfect squares. Number 8, we can take the square root of 1, which is 1. We can take the square root of m6, which is m to the 3rd. It is the difference of two perfect squares. So we write it once with a subtraction sign, once with a positive sign. Number 9, 36s squared minus 4t squared. All the numbers are perfect squares. All the variables are even numbers. So we take the square root, 6s minus 2t. Write it one time with a subtraction sign, one time with a plus sign. Last one, we have x squared y squared plus 196. Is 196 a perfect square? Yes, indeed it is. The square root of 196 is 14. So we take the square root of the first term. We take, oh, wait a minute. Both terms are perfect squares, but I did not notice right here in the middle we have a problem. This is supposed to be the difference of two perfect squares, which means it has to be a subtraction. This is the sum the addition of two perfect squares. This does not work with this. So that's a little practice on that. Now, good luck on your assignment.